Hey everyone, welcome back to the channel. Today we are going to cover trig reduction with the help of a calculator. To start, I'm going to define 4 rules. If you learn these 4 rules, that will be sufficient to do all trig reduction questions in grade 11 and grade 12. The first rule, if you have 180, the function stays the same. 90 and 270, function changes from sine and cos. 360s cancel, and in rule 4 we see that we need to sub 1 into the calculator to determine the sign. Let's see how these rules are applied in practice. Is cos 180 minus x. We see that this is the first rule because it is 180 and 180, therefore the function stays the same. So this is going to be cos x. Now, after applying rule 1, we then need to apply rule 4. So we always apply rule 4. After applying 1, 2, or 3, we always have to apply rule 4. What does rule 4 mean? It says sub 1 into the calculator to determine a positive or a negative. If this is our original equation, all we need to do is to sub in cos 180 minus 1 into our calculator. And if we sub that into our calculator, we are going to get minus 0.999. Now, since this is a negative, our answer here is a negative. So cos 180 minus x is equal to minus cos of x. The second question is sine 180 minus x. Again, it is the first rule, so this is sine x. In order to determine whether it's a positive or negative sine x, again we are going to use rule 4. So in our calculator, wherever we see x, we replace it with 1. So we plug in sine 180 minus 1 into our calculator. We get 0.0174 ... So that's a positive. So you don't need to write this down. You can just plug it into your calculator and see if it is a positive or a negative. Since that's a positive, sine 180 minus x simplifies to positive sine x. The next question, let's look at tan 180 plus x. Again, it is the first rule, so this is simply tan x. Now to determine whether it's positive or negative tan x, you are going to substitute tan 180. Wherever you see x, replace it with 1. Our calculator, we get a positive answer, therefore that's positive tan x. For the last example, let's look at sine 360 minus x. Now sine 360, as soon as we see 360, we are going to use rule 3. Rule 3 says that 360s cancel out, so I can cancel that 360 out. What will be left? We'll just be left with sine of minus x, because that minus x remains. This simply becomes sine of x, but again we're not sure whether it's positive or negative, so to determine the sign, we substitute sine of minus 1 into our calculator. We will get a negative value, therefore it's minus sine x. Let's try a few more examples. Question 5. What happens if we have sine 90 minus x? Well, we know if it's 90 or 270, we're going to use the second rule, which says the function changes. Therefore, this is cos x. To determine whether it's positive or negative cos x, we substitute sine 90 minus 1. That will give us a positive, therefore it's positive cos x. Let's look at cos 270 minus x. Since it's 270 there, again we are going to use the second rule. The function will change, so that cos becomes a sine, so therefore that's sine x. To determine whether it's positive or negative, we need to substitute cos 270 minus 1 into our calculator. We will get a negative, so that's minus sine x. Let's try the next one. Let's assume we have tan 180 minus x. 180 will mean we can use rule 1. Therefore, the function is the same. So that's tan x. In order to determine whether it's negative or positive, we substitute tan 180 minus 1 into our calculator, and we get a negative value. Therefore, that's minus tan x. Now that we've learned the rules, let's apply it to a question from a past year paper. So this is the standard that we are going to be tested. This is a 6-mark question from a grade 11 past paper. Before we continue, I just want us to be aware, if you have a tan x, more likely you'd have to simplify it into sine x over cos x. And that's a rule that we have to learn. So tan x is equal to sine x over cos x. That's not really a reduction rule, that's just the definition of tan x. Okay, now that we have that out the way, let's start our question. For the first one, sine 90 minus x. Because that is 90, we are going to use the second rule. So the function changes. So that sine becomes a cos x. But we need to know the sign, whether it's positive or negative. So we substitute sine 90 minus 1. That gives us a positive. So that's a positive cos x. I'll put that in brackets. Times. This is cos 180 plus x. So 180 means we are using the first rule. Therefore, the function stays the same. So it's again cos x. In order to determine whether it's positive or negative, I need to substitute cos 180 plus 1. That will give me a negative. So I'll put negative cos x in brackets plus tan x. I'm going to write it as sine x over cos x times cos x stays as is. So that's that cos x. Now here, we know the rule is going to be the first rule again. So since it's 180, the function will stay the same. So that becomes sine x. In order to determine whether it's positive or negative, we need to substitute 1 minus 180 into our calculator. So wherever we saw x, we need to replace it with 1. If we substitute that into our calculator, so if we write sine of 1 minus 180 into our calculator, we will get a negative value, so that's minus. I'm just going to put that in brackets so we know to multiply. If we simplify this, cos x times minus cos x gives us minus cos squared x plus, over here, cos x and cos x will cancel out, so I'm just left with sine x times minus sine x. That's minus cos squared x. Sine x times minus sine x is minus sine squared x. And this is minus cos squared x minus sine squared x, which is minus 1. And this is coming from the rule cos squared x plus sine squared x equals to 1. I just multiply everything by minus 1, so minus cos squared x minus sine squared x will therefore equal to minus 1. And that's it. We've solved the first question. Let's try the next question. This is from the 2024 March paper, so this is very similar to what you will be tested on. Let's attempt it. I do apologize for the low quality image, but let's persevere nevertheless. That's a 180. Therefore, we will use the first rule, sine x. To determine whether it's positive or negative, we have to substitute sine 180 plus 1 in our calculator. We'll get a negative. Therefore, that's minus sine x. For the next term, we have 90. Therefore, we use the second rule, which says the function changes. So that sine is going to change to a cos. So it's cos x. To determine whether that's positive or negative, again, we need to substitute 1 in place of x. So sine 90 plus 1, put that into our calculator, we will get a positive. So that's sine x times positive cos x all over tan minus x. Now, tan minus x, in order to determine the sign of this, we substitute tan minus 1 into our calculator and we will get a negative. Therefore, tan minus x is minus tan x plus sine x stays the same times. That's a 90, so the function is going to change. Therefore, we have a sine x. But to determine whether it's positive or negative, we need to substitute cos 90 minus 1 into our calculator. We will get a positive. Therefore, that's positive cos x. I can put that in brackets. That's multiplication. Now, to simplify this, we'll start by cancelling the negative signs. Tan x can be rewritten as, so let's first leave the top as is, so sine x times cos x divided by, tan x can be written as sine x all over cos x plus sine x times sine x is sine squared x. When we, now to simplify this, let's first note that that is a fraction and we are dividing. So we are dividing by a fraction. When you divide by a fraction, you invert and multiply. So that's the same as you write the numerator as is, sine x times cos x. Since we are dividing by a fraction, we have to invert the fraction. So instead of sine x over cos x, it becomes cos x over sine x. So we invert and multiply plus sine squared x. Sine x cancels with sine x and you're left with cos x times cos x is cos squared x plus sine squared x stays the same, so it's cos squared x plus sine squared x, and that's simply 1. And there we have it. We are done with trig reduction. And so we see that trig reduction is made easy using a calculator. Thanks, cheers, bye.